I want us to look at the technologies that are normally applied to increase the performance, speed, efficiency, and even capacities of a computer system. So generally, we have systems, we have programs, we have devices and hardware components that are there to improve and to enhance the performance of the computers or computer technologies, and those are what we call performance enhancement technologies. Now, these innovations seek to improve the system performance, optimize resource usage, and probably lessen the bottlenecks that are there. So there are few technologies that we are going to look at. Starting with the cache, we have overclocking, we have parallel processing, we have compression, we have just-in-time, we also have load balancing, we also have the use of solid-state drives over HDD drives. We also have virtualization. So basically, those are the few technologies that I want us to focus on today. We are not going to go deep into what they really are and how they work, but we are just going to mention how they help in the overall system performance, how they help in the overall improvement of performance of a computer system. So be my guest. So starting us off is what we call caching. So caching comes from the word cache. Now cache is basically some sort of memory that is closer to the processor, which the processor is able to reach very fast as compared to going to the main source of information, like going to the hard disk. So cache is normally placed closer to the processor, where the computer is able to reach what it wants very fast. So basically, why do we have cache? It's basically to reduce what we call latency. Okay, this is the time the computer takes to fetch the information. So basically, to reduce that time that the computer will take to fetch information from the hard disk into the processor for processing, into the CPU for processing, then cache memory had to be built or to be placed closer to the CPU so that it can reach it very fast. It can reach the cache memory very fast as compared to going the extra mile or the extra distance, taking time to fetch information from the hard disk. So to reduce latency access, caching involve storing frequently accessed data into faster and closer storage location. Now this faster and closer storage location is what we call cache. So it can be used on several scales, including this the CPU, disk, and web browser caches. Today we even have web caches within the web browser. So caching decreases the requirement to access data from the slow storage devices and increase the system responsiveness. So that is the reason why we have cache. Now, second of all, we have what we call overclocking. So overclocking is basically the practice of operating a computer component like a CPU or a GPU at a faster clock speed than its rate. Okay, so faster processing speed can basically boost or improve the performance by making sure the commands are executed faster. So when you overclock, you actually operate the GPU or the CPU at higher speed than it is supposed to be operated. So faster processing speed can boost the performance, but also produce more heat and necessitate cooling of the computer system. So it is important to know, to understand that. So in computer, we also have what we call parallel processing. We have what we call parallel processing. Now, parallel processing includes running several jobs or combination of concurrent by dividing them among several processor or core processors, or simply cores. So if you have so many work to be executed or to be done, the computer has got a way of slicing or dividing these jobs, then distributing them to different processors. Remember, most of the computer nowadays have more than one processor. That's why we talk of quad core, we talk of octa core in phones. So basically, these computers have different cores which are dedicated for specific tasks. So when the tasks are presented to the processor, they are divided into smaller chunks, then delegated to these other cores. Then that way, the general performance of the computer is greatly improved. For jobs that can be broken down into smaller independent units of work, parallel computing can basically and increase the performance of a computer in a very great way. Now, we also have what we call the compression. So basically, compression is a technology that is there to be used to reduce the size of the file. So compression technologies enable faster transmission. That's why even when you are sending data, if it is a bulk kind of data, you have to compress it fast so that it can be transmitted over the internet or over the network easily. So less storage space usage, that is what compression bring forth. It also make it quicker to transmit this data from one location to a different one. So data can be compressed while still maintaining its integrity by using of various technologies that are there. We have zip, we have gzip, and we also have a technology such as multimedia codec. So those are some of the technologies used to compress data in order to reduce their size to facilitate efficient and fast transmission over the network. Now, we also have what we call just-in-time compilation, right? So just-in-time compilation is probably a better way of making sure that whatever you have is executed very fast. Now, this is there to enhance runtime performance. So basically to enhance runtime performance, programming languages, those languages that are used to come up with the programs, so the one that are used to develop computer programs, and virtual machines uses just-in-time compilation. So before they perform, a portion of a program is normally translated into machine code. Now, that portion, you see, the portion is translated, then the rest are going to be translated later as the processing continues. So why is it done that way? So this is to make sure the performance is improved by lowering interpretation overhead, or as compared to getting the whole code and translating the whole thing. You see, it will take time. So in order to improve on time or to reduce time, just a portion of it is translated fast, then executed. That one will reduce the overhead cost of interpretation, and that will help the computer to perform even better. So we have what we call load balancing. Now, to maximize resource utilization and avoid bottlenecks. So of load balancing is used. Now, load balancing distributes network or computation or workloads over multiple servers or resources. So basically, to reduce workload, the computer has a way, or the system has a way of dividing workload between individual or multiple resources that are available for it. So it makes sure that the effort is allocated equally, increasing system responsiveness and efficiency. So that is the main reason why we have load balancing. Another way is of improving performance of a computer system is where we have what we call the use of solid state devices. Now, solid state devices are normally faster as compared to hard disk drives, right? Because of how they've been configured, because of how they are organized. They can be able to transmit data faster, or the computer can be able to access data on them faster because of the principles and technologies that are applied in their usage. Now, compared to the conventional hard disk, now that is solid state have higher rate and write speed because they use what we call flash memories technology. So that one generally lowers the lower data access latency and boosts overall system performance. Then finally, we have what we call virtualization. So within a physical computer system, virtualization instance or environment can be created using virtualization technology by executing different operating system or application on the same physical machine. So virtualization enhances efficiency and flexibility by making greater use of hardware resource. So normally when the computer is operating and it needs more memory, probably the memory that is there is not enough to accommodate all the tasks that the computer is performing. Usually the operating system will take up a portion of hard disk and create a virtual memory on it so that the computer is able to execute the task from there. So that is what we call a virtualization. So it creates what we call a virtual kind of memory. So that's how we end up with these systems being operated and making sure that our computers are faster and efficient. So these are some of the things that we need to look into in order to generally understand how a computer is able to work, how a computer is able to perform the tasks that are rendered to it. Because at the end of the day, we use computers to enhance our output, to enhance our performance. So in the same breath, the computer is also created or organized or configured in a way that it's able to optimize the resources and the softwares and the programs that are there for the maximum output. So thank you for joining me. It is a pleasure to always have you. Thank you for this the support. If you've not subscribed, please do so. Like and subscribe. Thank you.